A single bolt of lightning carries about a billion joules of energy and reaches a temperature of 30,000 degrees Celsius. That is 3 times hotter than the surface of the sun. Statistically, every commercial airliner in operation around the world is struck by lightning at least once or twice a year. But while you were cruising through a storm at 10,000 meters, nearly 33,000 feet, this apocalyptic discharge collides with the fuselage and absolutely nothing happens to the passengers. How does a metal tube flying at 900 kilometers per hour, or 560 miles per hour, survive an impact that would blueprint and pulverize a tree in a fraction of a second? Where does all that massive electricity go at the exact moment of impact? Why don't the highly sensitive onboard computers, which control the aircraft's flight commands, instantly short-circuit and shut down the engines in the middle of nowhere? And most critically, how do the fuel tanks, which carry dozens of tons of highly flammable jet fuel inside the wings, not explode from a million-volt spark? The answer to this aviation miracle comes down to a 19th century physics concept, the Faraday Cage, combined with extreme materials engineering. When lightning strikes an airplane, usually at extremities like the nose or the wingtips, the electricity doesn't try to pass through the cabin. Instead, it travels along the outer skin of the aircraft. Because traditional airplanes are made of aluminum, which is an excellent electrical conductor, the current rushes across the outer surface of the metal, wraps around the aircraft, and exits through another extremity, like the tail, continuing its path toward the ground. But what about modern airplanes, like the Boeing 787 or the Airbus A350, which are made of carbon fiber composite materials that don't conduct electricity very well? Engineers solved this with surgical precision. They embedded an ultra-thin copper mesh just beneath the aircraft's paint. This metallic screen creates an invisible conductive shield that forces the lightning to slide strictly along the outside. To complete the process, there are static wicks, static dischargers on the wingtips, small rods that help dissipate the accumulated electricity back into the atmosphere. If you look up videos recorded by passengers staring out the window during storms, you will find dozens of real clips of lightning striking the wings. Visually, it looks like the end of the world, a blinding flash accompanied by a deafening boom. But mechanically, the plane keeps flying as if nothing happened. The only real damage after landing is usually a small burn mark or a millimeter-sized scorch point on the fuselage where the lightning entered and exited, testing to the extreme. To ensure the system never fails, the certification of these aircraft involves brutal laboratory testing. Engineers use surge generators to fire millions of volts of artificial lightning directly at parts of the fuselage. They monitor the inside of the fuel tanks with high-sensitivity cameras to ensure that the metal thickness and rivet insulation prevent any internal microsparks. Every joint near the fuel is electrically sealed to eliminate even the slightest risk of an electric arc. The surprising conclusion to all this completely reshapes our intuitive fear of flying. In a storm, lightning is the least of a pilot's worries. That entire multi-million volt discharge is nothing more than a harmless light show for the aircraft's structure. The real danger in crossing a storm cell isn't electricity, but rather heavy hail that can shatter the windshield, severe downdrafts or microbursts that test the aerodynamic limits of the wings, or the temporary risk of the pilots experiencing flash blindness from the lightning. Engineering has shielded the airplane against electricity so perfectly that one of nature's greatest destructive forces has become mechanically irrelevant. If you respect the level of engineering that allows us to fly safely through storms, hit the like button to support the channel and subscribe. Leave a comment letting us know if you've ever witnessed lightning striking a flight. See you next time.